Good day, everyone, and once again we're back together, and we are looking at that November, actually the September 2022 exam. This is taken from the Eastern Cape, and it was a very interesting multiple choice section. So if you haven't subscribed, please just make sure that you're part of the family. Right, and of course, you can join in as a member if you do want to have those NBT sessions. Do join in as a member. You can go onto our membership features and look at all the valuable perks that we have. Right, now let's get right into it as you are preparing for those exams. Right, so they say to us 1.1, an object of mass m moves down the incline at a constant velocity as shown in the diagram below. Now, the operative word here would be constant velocity. So, if we were to take this object and we say, look, it's going down the incline, right, it would mean that parallel to the incline, it would be the parallel component of gravity that is pulling this thing down the incline, right? But we also have the frictional force, right? Now, for us to have it moving at a constant velocity, it would mean those two forces are balanced, right? So that would simply mean that F net is equal to 0, first of all, because of constant velocity. So that's Fg parallel minus the frictional force, and that would become 0 in this case. And so it means that Fg parallel would be equal to the frictional force. And of course, I've said this more than enough times that remember that Fg parallel, this is mg, the sine of angle theta being the angle of elevation, right? So they say which one of the following expressions represents the magnitude of the frictional force acting on the object, right? And of course, for the frictional force there, we know that we would actually take mg, the sine of theta. So B would be the correct answer. Right, so let's go on to the next one. Okay, so they say to us a car of mass m is traveling at a constant velocity and has a momentum p, right? They say the driver notices that there's an object rather ahead of him, and applies the brakes so that the momentum of the car changes to half p. Which one of the following diagrams below correctly shows the relationship between the initial momentum, the final momentum, and the change in momentum? Just to quickly have a look at it, ladies and gents. So we know that the change in momentum, right, would be equal to momentum final minus momentum initial, right? So we know that the final momentum is actually a half of p, right? So that would be a half p minus the initial momentum. So assuming that, of course, in the original direction, the momentum is positive, right? So that's minus the initial momentum. And so what we get there is minus a half of p, right? So that means that first of all, the change in momentum is negative. It should be in the opposite direction. And in this case, it should be a half of p, right? The final momentum, we said, is a half of p, and the initial momentum is p, right? So now, in this case, it means that we're going to look at a vector diagram that represents that well. So there's the initial momentum. So when we look at option A, right, initial momentum looks okay, but look at that change in momentum. Can you see it's not in the opposite direction, right? So in this case, this cannot be the answer. But when I look at B, our initial momentum looks correct, right? Our final momentum in this case is a half of P, right? And our change in momentum is in the next opposite direction, and it's actually a half of p as well. So B does look somewhat correct, and if you don't mind, I'm not going to waste any further time analyzing the other ones. We've got our right or correct answer. Right, so the next question, they say we've got a hot air balloon that is moving upwards at a constant velocity v, right? They say stone is dropped, okay? So note they say that it is dropped, so that simply means that even though it is dropped, please remember, ladies and gents, because it was in a moving air balloon, in this case, the stone will actually assume the velocity, or the initial velocity of the stone rather, will assume the velocity of the air balloon, right? Because they were all moving together. They say, what is the velocity of the stone at the instant it is dropped from the balloon? Well, it should be v, also going upwards. So in this case, the correct answer there should be v, okay? Should be C rather. Right, so the next question, they say an object an object is thrown vertically upwards from R that passes point Q, right? And reaches a maximum height at point P. Ignore the effects of air friction. Right, so they say which one of the following is correct as the object moves from point R to Q, right? So we are looking at motion from R to Q. They say the total mechanical energy has increased. So remember, mechanical energy in this case in an isolated system remains constant. So that would not be true, right? And then they say the total kinetic energy at P is 0. Now remember, we are looking at motion from R to Q, so that has absolutely nothing to do with P, right? And they say, otherwise that would have been correct, right? But remember, they said we consider motion from R to Q, right? They say the decrease in kinetic energy is equal rather to the increase in potential energy. That does look correct. Remember, in this case, we know that it's an isolated system, so you are losing kinetic energy, but you are also gaining potential energy. So that would be true, right? They say in D, the average work done on the object is equal to 0. That would not be true at all, right? Now, let's go on to the next one. They say the net work done by a constant force F, right, that acts on an object to increase its velocity from 0 to v is W. Now, ladies and gents, in these kind of questions, right, what it requires us to do is to set up an equation that relates W and those velocities as well as F, if that is possible. So if you think about it, what relates work done and velocity? That's the work energy theorem, isn't it? So the net work done is equal to the change in kinetic energy, right? So we know in this case that's going to be, they say the work done is W, so we'll keep it as W, right? So this would be half of mv squared, vf squared, minus half mvi squared, right? Now note, for the first instance where we are talking about work done W, right, we said our final velocity is v, right? Our initial is 0. So that would mean if the initial velocity is 0, it makes this entire term become 0. So we are going to get rid of that, right? And we know our final velocity is going to be v. So that's going to be half mv squared. So that means W is equal to half mv squared, right? Now, they want to know the net work done by the same force F, right, on the object to increase its velocity from v to 2v, right? So we want to now find out what is the new work done, okay? So I'm going to say the new work done, okay, in this case would be half mvf squared minus half mvi squared. But remember, what is our final velocity in this case? Our final velocity is 2v. So going to say this is half m times 2v squared, right, minus a half m What is our initial velocity? That's v. So that's half mv squared, right? And so if we work this out, we end up with, now think about it, you're going to have 2 squared, which is 4, right? So you've got half m times 4v squared minus half mv squared. Okay, so notice in this case that if I take the 4 to this side, okay, remember that multiplication is commutative, right? So this would give us something to the tune of, so this is 4 half mv squared minus half mv squared. Okay, I hope that you can see that will actually give us 4 times, that's half mv squared. Okay, sorry about that. In fact, I should be doing it over there. That's 4 times half mv squared, okay, minus half mv squared. Okay, now 4 times something minus 1 times something will give us 3 times half mv squared. And I hope you can see that actually this gives us, this is w, so that means that our answer would be 3 multiplied by w, because w is a half mv squared. So that means the correct answer there should be D. I hope I managed to explain that well enough, right? You can look at it in whatever way that you want. If you wanted to, you could have said, well, that gives me, so if I multiply half times 4, that would give me 2 mv squared, okay? 2 mv squared minus half mv squared, and that would give you 3 over 2 half mv squared, right? So if you take 3 over 2 mv squared, this is the same as saying 3 times a half mv squared. I hope that makes sense. Still, you'd still get to the same answer. Right, so the next question. Right, they say to us, we've got an astronomer that observed that a light from a distant star undergoes red shift. That's very important. So we remember when we are shifting to the red side of the spectrum, that's where we've got longer wavelength, isn't it? And we've got, in this case, a lesser frequency. So they say, which one of the following combinations regarding the observed wavelength and frequency correctly explains this shift? Right, we did say that when we're looking at red shift, we are decreasing in this case, or rather it's got longer wavelength, so it's got increased wavelength, right? But in this case, decreased frequency. So it does look like A would be the correct answer. All right, so I hope that you are still following and tracking, right? So they say we've got 2 charged spheres, A and B, that are carrying charges Q and 2Q respectively, right? They say they are placed on insulated stands as shown in the diagram below. Sphere A exerts a force of F, right? So sphere A exerts a force on F on B, right? And they want to know what is the magnitude of the force exerted by B on sphere A. Now, please remember, ladies and gents, we would always apply Newton's third law of motion, right? And it says if body A exerts a force on body B, then body B would exert an equal but opposite force on A. So the magnitude of that force would also be F. The only difference is that it would be in the opposite direction. So the answer there is C. Right, as we move right along. So they give us in 1.8, we've got a battery with internal resistance R, right? They say it is connected into a circuit as shown in the diagram, right? A conducting wire of negligible resistance is now connected into the circuit across the points X and Y. So what I'm going to do is, before we even go further, all right, let's do exactly that. Connect the two together. Right, so we put a wire there. Okay, and they want to know which combination below correctly shows the changes to the readings on the voltmeter and ammeter. Right, now I want you to please note the following. So we note here that by putting wire XY, okay, I want to just use a different color there so that you can see it. So the total current would pass through internal resistor. We know the current would move across R. But what happens? Now the current, all the current would now follow that wire there and go back to the battery, right? So what does that mean? It means that we cancel this entire part of our circuit. Okay, so and by the way, that's because current is no longer moving there, right? So we want to know what will happen to the voltmeter reading, right? So what have we in fact done? By removing those resistors there, it means that our external would decrease, right? Because we've moved both of them, so it means that our total resistance would now decrease, right? Because we don't have that parallel combination anymore, right? So as a result, please remember, V external always follows on what happens to R external. So that means V external will definitely decrease, right? However, what happens to the value of current, right? They wanted to know the reading on A. Remember, because there's no current that goes on the ammeter anymore, we might as well say the ammeter reading would also decrease because there's no current passing through it. So both of them will decrease. So in this case, the correct answer there would be C. All right, just going back to our original color. So the correct answer would be C, right? So they both decrease. Right, and then we go on to 1.9. They say to us the graph below represents the EMF generated versus the time for an alternating current generator, right? Now they say to us the speed of the generator's coil is now doubled, right? So please remember, the EMF is dependent on the change in magnetic flux divided by the change in time. Now, if you change or you increase the speed of rotation, what are you doing? By increasing the speed, it means you are taking less time to complete one cycle, right? So that means that the change in T is going to decrease, okay? Remember, the more you increase the speed, the shorter the time it takes to complete one cycle, right? But remember, what happens when you decrease the time or when you increase the speed? The value of the EMF also increases, right? So it means that EMF will increase, right? But now, what happens to the period of the graph? Remember, let's say if you took a certain amount of time, by increasing the speed, it means, and doubling the speed for that matter, it means you're going to take half the time to do the same thing. So what do we expect of our graph? Our EMF value should be double what it was before, right? But our period should actually be half, right? It takes half the time to complete one cycle. Right, so that is what your graph would somewhat look like. Okay, right, and I hope that you are still following. So EMF would double, but the period would half. So therefore, the correct answer there would be B. Right? Okay, so the last one. They say the photoelectric effect provides evidence of the fact that. Okay, please note in this case, the photoelectric effect shows us that light can in fact behave as a particle, right? It shows us the particle nature of light. And so 1.10 has an answer in D. All right. And that is how the cookie crumbles, ladies and gents. And I hope that you've been able to follow on and appreciate, this section. And please, when it comes to the multiple choice section, you have to learn it. You have to learn how to answer the questions. And I hope this video has been able to help you do that. Please do note that there are other multiple choice sections that I've done in the past. Please have a look at them and you will be assisted. Otherwise, ladies and gents, I will see you next time with the next video. Please do prepare well, and I wish you all the best for your upcoming exams. From me for now, it's ciao